All right, so we're going to go ahead and take a rod. And where you find these numbers, and I didn't mention it while we were looking at the electrodes, where you find those numbers are on the uncoated portion, just below the uncoated portion of the electrode. It's usually stamped in there. It has different colors like a red stamp or something like that. Okay, so these actually have a code, and you guys need to understand as a welder what the codes mean. So, the 60 stands for tensile strength, and this is 60,000 pounds per square inch. What that means is it takes 60,000 pounds of shearing motion to break that metal. 60,000 pounds. The tensile strength is the 60,000 pounds per square inch shearing force. So we saw those other rods, which were 70-18, 80-18, 90-18. So what does that mean to you as a welder? This is a very weak, considering, connection. It only takes 60,000. Where the 90-18 takes 90,000 pounds per square inch to tear it apart. So what that is that will hold longer and heavier equipment. So let's say, for instance, we take this to the usage. If I want to use this 60-10 to put something together like a trailer, it will work. It's functional. But it'll only take so much pressure and then the welds will break. Whereas the 90-18, 70-18, 90,000 pounds, it'll take a lot more. So that's when you need to know what you're going to use for what job. All right, so the 1 in the 60-10 has what positions you could use it in. There are only 4 positions in the welding field, 4 positions. If you take a look at this chart, there are only 4 positions: flat, horizontal, vertical, and overhead. So each one of the codes, which are found in the book, will tell you what positions this rod should be able to be used at. The rod right there can be used in any position. That's what the 1 stands for. So there's 2, 3, and 4. Little recap, the 60 stands for tensile strength, 60,000 pounds per square inch. The 1 stands for the position that you could weld it in, and we talked about the 4 positions. The last 2 numbers, they are connected together, and what that stands for is the type of flux that's on the outside. It might be calcium, it might be high hydrogen, it might be whatever it is. We can look it up on the chart. It might be a different type of flux. What does that mean to you as a welder is the flux type tells you how quick it's going to dry or solidify. So if you did a quick solidifying flux, you know that the 60-10 is quick because it cuts through grass, mud, and all kinds of stuff, rust, and it'll dry quick. But if we get something like a 70-18, right, the 18 might be a different thing. That's why they're cover passes. It might take a little bit more for them to solidify. Okay. Okay, these welding books, you could get them at bookstores. You could get them at, I've never seen a lot in the welding supplies, but there's a ISBN number in the book that you can look. This is always glad to refer, this is always great to refer to. So if you have one of these, you've got everything that you need to weld. It'll tell you how to weld every process. It'll tell you what to use, as long as you know how to look it up in the book. This is a 3rd edition. I've got a 5th edition in there, so welding doesn't change a lot, but you should keep up with the editions. Now this book, I'm not sure how much they cost, probably about $120 because it's a training book. This book is good to have with your library. Okay. Since we are talking about electrodes, on page 348, it starts off on the composition of the electrodes. It tells you what we talked about with the tensile strength. It tells you what it has for the different types, what you need it for, right? If you turn the page, it'll explain the flux, right? It'll give you an example of different types of identifications on the welding rod. Sometimes it might be a different welding rod and you might have to look it up and see what it actually is. Over here, this gives you the different types of flux, the amperage you would use, and anything else that you need to know. So this is on page 340 or 350, this chart. And these charts talks about the classifications. That's where you go when you need something to look up. This is all good to have. This is all good to know. This is great to refer to. Table 12.7. This is one I wanted to point out. This is the different electrodes that we talk about, but it tells you what kind of covering. Like the 6010 is a cellulose covering. The 6011 is a cellulose covering, because remember I told you those two act about the same. But if you take a look at the 7018 or the 7048, this one here is a low hydrogen iron powder. So the low hydrogen powder or hydrogen powder tells you that it's a cover pass. This rod right here, an E704, 8, that tells you what position are you going to weld it in. Overhead. So if you're welding it in overhead, it has to solidify a little quicker because you got gravity that's coming down, and overhead is basically straight up and down. So this tells you what the covering type is. This also tells you what exactly amperage to use, right? If you're going to do fillet welds, what kind of amperage to use, and anything that you need to do things. Now we're going to look into the theory of welding, right? There are certain things that happen, and one of the things that I like to explain, it equates to riding a bicycle. If you think about it, how much do you have to think about riding a bicycle? You got to think about pedaling. You have to think about keeping your balance. You have to think about keeping your hands on the handlebars. You see some people riding without their hands on the handlebar, but that could cause an accident. You have to think not only the balance, you have to think about the speed. If you're going too slow, what happens? You fall over. So welding is almost like that. You've got a lot of things that have to come together to get a good weld, right? When the moon is in the 7th house and Jupiter aligns with Mars, and Venus surrounds the planet, this is the dawning of Aquarius. So everything has to be in alignment. This right here represents the electrode. If you take a look at it, this is the direction of travel. So you're coming from left to right. If you're a right-handed welder. If you're a left-handed welder, you're going to come from right to left. So if you're a right-handed welder, your rod has to be tilted approximately 20 degrees, 15, 20 degrees. What that does, it gives the opportunity to flux to create the atmosphere that it needs to. You need to be about a 1/16 of an inch above the metal. Now, I don't know why I said about like that. All right, a 1/16 above the metal so that your arc is created. If you are too high, let's say a 1/4 inch or 1/2 inch, it's called long arcing, and your arc kind of moves in an erratic shape. Instead of being straight down, you're like all over the place. I do have some examples of welds on the side of my podium, and you could actually, when we get back into the shop, you can come in and you can look and see what's happening with your weld. Even though that's my job, I'll tell you what's happening to your weld. All right, so it's got to be above the metal, about a 1/16 of an inch, 20 degrees, 15 to 20 degrees angle in the direction of travel. And you can't be too slow. If you're too slow, it doesn't create the bead that we're looking for. So we're going to talk about two different things. We're going to talk about speed, because you have to have a certain speed, and we're going to have to talk about timing. So your speed has to equate by your temperature. The higher the temperature you have, the faster you have to move. The lower the temperature you have, or what we call amperage, the lower amperage that you have, your speed is slower. Right? So if we take this to 100 amps, you're going to have to make your speed a lot quicker than you think, because it'll be too, if you go too slow, it won't create the bead. Now, timing. You guys have to know the difference between speed and timing. So one of the things that I like to tell my class is that you've got to picture a metronome. And if you don't know what a metronome is, basically it's a cadence keeper for piano players.